Hello everyone, today we're going to look at multiplying radical terms. So the basic form is going to be a root b times c root d. So we multiply what's outside of the radicals, so a times c, then we multiply what's inside the radicals, b times d. And don't forget that you always have to simplify. So in the new BD, is there a factor that's a perfect square? So as our first example, we have 3 root 6 times 2 root 2. So I multiply the numbers outside of the radical, 3 times 2, and I get 6. And then I multiply the numbers inside the radical, 6 times 2, and I get 12. And then I look at 12, and I say, okay, does 12 have any factors that's a perfect square? And it does, 4. So when I take out the root 4, I have a 2. And I still have inside of my radical the 3, since 12 is 4 times 3. And then I multiply again what's outside the radical, 6 times 2, and I get 12 root 3. Remember, however, that it is always easier to simplify before you multiply. So, for example, 4 root 30 times root 24. You would not want to multiply the 30 times 24 and then try to find square factors. So you want to simplify before you multiply. There are different types of simplification you can do in this case. I could either try to simplify, say, root 24 first. It has a factor of 4 that's a perfect square. I could pull that out. Or I could look at the 30 and the 24 together. And what I'm going to do is I'm going to notice that 30 and 24 both have a 6 in common. So I'm going to look really for the GCF. What's the greatest common factor? So I'm going to rewrite 30 as 6 times 5 and rewrite 24 as 6 times 4. And then I can distribute this square root across the multiplication. So I have the 4 on the outside, root 6, root 5, root 6, root 4, and then from there I'm going to simplify. So I still have my 4. My square root of 4 becomes my 2 out here. And then I also have root 6 times root 6. So the square root of 6 times the square root of 6 is root 6 squared. And those two cancel each other out, and I'm left with my 6. So if I notice that inside the square roots they have a GCF, a greatest common factor, I can pull it out. And a root 6 times a root 6 is a 6. It's out, and now I just have to multiply everything that's left over. So 4 times 6 times 2 is 48, and the only thing inside the square root that I still have is the 5. So let's try it with another one. 3 root 15 times 2 root 30. So again, I could do it the long way. I could multiply 3 by 2 and then multiply 15 by 30. And then of that 450, I could look for a square factor. But that's a really big number. So instead, I'm going to notice that 30 is 2 times 15. So I'm going to factor 30 into 15 and 2, and then I have root 15 times root 15 is 15. So I'm going to pull that out. The only thing left inside the square root is this 2. So I have the 3 and the 2 from before, the 15 that they had in common that I took out, and then the square root of 2. 3 times 2 times 15 is 90. So I end up with 90 root 2. Let's try another one. 40 times 3 times root 24. So again, I don't want to multiply 40 by 24. That's going to give me something that's way too big. But instead, I'm going to notice that they both have an 8 in common. So I'm going to factor 40 as 8 times 5 and factor 24 as 8 times 3. And I'm going to pull out my root 8 times root 8, which is 8. So I have the original 3 my new 8, and then I still have the 5 and the 3 inside the square root. And then multiply that, and I get 24 root 15. So let's try another one. 5 root 35 times 2 root 14. Again, do not multiply 35 by 14. Instead, notice that they both have a 7 in common. So 35 becomes 7 times 5. 14 becomes 7 times 2. I'll pull out the 2 root 7s that become a 7. So I have my original 5 and 2 outside of the square root. My root 7s become 7, and then I still have a 5 and a 2 inside the square root as well. Multiply that through, and I get 70 times root 10. Okay, we'll try a couple more. 4 times root 18 times 2 times root 8. Again, I want to notice that they have things in common that I can pull out. So 8 and 18 have a 2 in common, so I factor 18 as 9 times 2. I factor 8 as 4 times 2. And then if we notice, root 9 is 3, root 4 is 2, and then root 2 and root 2 is another 2. And I actually don't have anything in my square roots left. So we got 4 times 2, that's the original 4 and 2. And then the 3 and the 2 are from the square roots, and then the other 2 is from the 2 root 2's. So everything inside of my square roots actually end up canceling out. And I'm left with just 96. So let's try another one. Root 50 times 3 root 6. Okay, so again, I don't want to have to multiply 50 by 6 and then look for square factors. So instead, I'm going to factor my 50 into 25 and 2, and then realize that 6 also has a 2. So I end up with root 25 times 2 times 3 times root 3 times 2. So root 25 becomes a 5, the 2 root 2's become a 2, and then I still have a 3 outside the square root and a 3 inside the square root. So I have 3 times 5 times 2 times the square root of 3, and that gives me 30 root 3. And then for our last one, we have 6 root 80 times 2 root 40. I have 80 and 40. Their greatest common factor is a 40. So I'm going to rewrite 80 as 40 times 2. And then I have the 6 and the 2 outside the square root. The square root of 40 times the square root of 40 is 40. And then inside the square root, I still have just the 2. Simplify that, and I have 480 times the square root of 2. Okay, so it's really, really helpful if you simplify before you multiply. And that's true no matter what it is you're doing, whether it's fractions or square roots or even square roots inside of fractions. Always simplify before you multiply. Okay, so make sure that you read through the section and try the homework, and let me know if you have any questions. Thanks.